Hello guys, welcome back to my channel. Mason African Motives, still working on engineering science N3. So actually in this platform we shall be focusing on question 1, which is from the question paper of November 2018. That is on motion, energy and power. So we just want to see what we are given in this case. As you can see, that is the whole question, and everything there was just 16 marks. So I hope it's gonna be quick. All right, so the first question is to state the law of conservation of energy in words. So they want us to state this in words. Remember, it's all about the energy, that it cannot be created or destroyed. But as we know that energy actually can be converted from one form to another, that is either potential energy to kinetic energy. That is how actually you can work out with energy conversion that is will be taking place. The way we'll be talking about E top is equal to EK at the bottom. This one will be at the top, something like that. So that is all about energy. You're converting to one form, mechanical to electrical, yeah, so forth. So there on number 1.2, we are then given a motor car with a mass of 0.9 ton. All right, so take note, we've got a mass here of 0.9 ton, which is actually mass must be in kgs, as we know. So to convert to kgs, you have to multiply by 1000, because remember, in a ton, in 1 ton, we have got 1000 kilograms, which is 1000 kgs. So you have to multiply by 1000, which is going to give us 900 kgs. So we have got the mass there of 900 kgs. All right, then we are given is parked on an incline AB. Okay, so that's our AB of 1:20, which is we are given the ratio there. So that means our theta is going to be arctan. Remember, it is going to be arctan 1/20, like that, 1/20. So that is going to be our theta. And I don't know if we are to find it now, or we just leave it like that. Okay, we can just leave it like that. The motor car departs from rest. Take note, from rest. From, this is where you are starting, your starting point from rest, which means at rest there is no movement. All right, so that's your starting point, and there's no movement at that starting point. So what does that mean? It means that's a 0 meter per second for the velocity at the starting point. Okay, within 12 seconds. So we are also given the time of 12 seconds in this case, and reaches a speed of 144. From this speed at rest, it is now at 144 kilometers per hour. That is our final velocity, but we have to write this in meters per second. So remember the conversion, that a meter per second is equal to 3.6 kilometers per hour. All right, that's 3.6 kilometers per hour. So we have to divide by 3.6. So 144 divide by 3.6. All right, that's gonna give us something like 40. So this will be 40 meters per second. All right, so I think all the information is there, and if all friction losses is neglected, which means we are not having the losses, so the frictional, just put it as a 0. All right, then here, so this is not W, this one, this is mass, not, so this is wrong. This is mass is equal to 0.9 ton mass, then weight, which is W. Remember, weight is equivalent to mg, not this one. This is mass. All right, so the first question is to calculate the acceleration. Calculate the acceleration of the car from A to B. All right, so this is what we have from A to B. Here we have got the initial velocity, the final velocity, and the time. which was taken from A to B. So we can connect this. So from our formula sheet, I have the formula sheet here? But from our formula sheet, actually we can take out the formulas. Let me just show you guys. But we'll be having these formulas here, so you can actually connect the formulas, these ones for linear. Okay, so you can just take which one is best, but as you can see, this one is the best here. But these formulas, you're supposed to actually know how to apply them. That is the most important thing, because you'll be given these formulas in your formula sheet. Okay, so this is 1.21, so I'm going to take this one. V is equal to U plus AT. Since we have got this V is there, U is there, and T is there, and what we only need is the acceleration, which is this A. So I can make the acceleration equal the subject, or I can just substitute here because I have V, which is 40. So I can substitute 40 is equivalent to U. Remember, our U was a 0. So that's 0 plus AT. So we've got AT, which is our T in this case is 12. So it's A times 12, which is the same as 12A. So which means 40 is equivalent to 0 plus any number. We are going to remain with this, which is 12A. So to find A, definitely I have to divide by 12 in this case. So from your mathematics, guys, you have to divide there. So this is going to give us the acceleration, which is something like 10 over 3. So we are going to obtain 10 over 3 meters per square second, or that can be as a decimal 3,3. So it's going to be like 3. So it will be just like this, meters per square second, or you can write this as meters per square second like that. Still, it's one and the same thing. That is your acceleration. All right, then the pulling force. So remember, we are taught to neglect all other forces that we are going to have. So therefore, the pulling force actually, that is the applied force there. The force that is being applied, and we know that F applied is equivalent to MA. That is what you're going to have there, which is mass times acceleration. So you've got the mass 900 is there. The acceleration, we just got it now, so it's 900 times. So it's going to depend now with the answer that you obtained, because if you obtained 10 over 3, you're going to have something like this. All right, or someone has got that 3,3333. You are not going to obtain exact answers though, because this one is going to obtain 3000 newtons, right? And this one is going to obtain 2999,7 newton. This is what you're going to obtain, which is a slight different, as you can see, guys. So depend with the value of A that you're going to use. But if you use this one, please maintain this answer. If you use this one, maintain this answer also. So that is what you're going to have for the pulling force that we have there. Then the length of the gradient, definitely the gradient, we are referring to this, guys. This one is the gradient here. So this is the length of the gradient, which is actually the displacement. So you can refer to it as S, or you can put whatever way that you want. Okay, but this S is affected from A to B, which means it is going to use this information also. And remember, now we have got the acceleration of 10 over 3 meters per square second, or 3,333. So we have got the acceleration now, the time, the velocities, they are there. So which formula are we going to use? So there are so many formulas, I'm just going to list them down. We have got this one, 1.23. S is equivalent to U plus V is also part of the formulas that you can actually use. This one, I love this formula. But there's also this one that most people use, and I wonder why. V squared is equal to U squared plus 2as. Then they make s to be the subject, which is v squared minus u squared, then which is definitely going to divide by 2a like this, which is equal to s. So still you can use this one. All right, so me using this one, it is not going to affect me why I'm using the values which were already there. The u was there, the v was there, the t was there. So my answer is not going to be affected by anything because I'm using original values. That's the advantage of this formula. So u is 0 plus v, which is 40. So take note, I'm using the values which were already given, not the ones that I calculated, which is 12. But this one, acceleration, remember, you are the one who calculated this. So which means if this value is wrong, your answer is going to be also wrong. So take note, guys. It's best for you to use the values which were already given than the ones that you calculated by yourself. Anyways, any formula is best for you guys to use. So you can use this one, or you can just use this one. So using this formula, I'm going to obtain direct 240 meters. Remember, it's displacement measured in meters. But if you were to use this one, you substituted your values, it's going to be s is equal to v, which is 40 squared minus u squared, that is 0 squared over 2 times a. Remember, on our a, we still have a problem. There was that a which was 10 over 3 and another one that was 3,33. So you're going to choose according to the one that you wrote on your answers there. So if you use 3,333 like this, still your answer is going to be the same, but it will be a slight different because it will be 240,024 0024, something like that, which is 240,123, which is 024 to 3 decimal places. So as you can see, your answers are slightly different, but if you use 10 over 3, you're going to obtain a direct 240. So that's why we said we have to choose which one is best according to what you wrote there. All right, so that is the length of the gradient. What about the power of the car's engine? Power, guys. What is the formula for power first before we talk about anything? Power can be energy over time, isn't it? Power can be energy over time, guys. So let's see this formula if it's gonna work. But which energy are we talking about now? Which energy are we talking about? Definitely this is, because when you're talking about power, there's movement, so which means you're talking about the kinetic energy, not potential, but the kinetic energy over the time that is taken. So this will be joules per second, which is actually measured in watts. All right, so but do we have the kinetic energy? Because we never talked about the kinetic before. We didn't. All right, so you have to calculate the kinetic energy. So where are we going to have the kinetic energy? Remember the formula for kinetic energy, that's it's equivalent to half mv squared. That's our kinetic energy. So definitely I'm going to use the velocity when there was movement, not the one that is the initial, but the final when there was movement. So that I have the total kinetic energy there. So it's half times the mass. Remember, our mass is 900. Yeah, that's our mass, 900 times v squared, which is the final velocity of 40, this one. So it's going to be 40 squared. All right, so simplifying this or combining this, you're going to obtain 720,000 joules. Remember, this is energy, kinetic energy measured in joules, or you can write it in kilojoules. So now I have this and I have got the time also. So definitely I'm just going to substitute here because what I needed was the kinetic energy. Now I have this kinetic energy, which is 720,000 joules over the time, the one that we are given from A to B. The time that was taken was 12 seconds. So we're going to divide by 12. So this is going to give us joules per second, which is actually in what? In watts. So if we divide the two, we are going to obtain 60,000. So this will be 60,000 watts. Okay, because it's power, remember. So that is what you're going to have. So which means you can leave your answer like this, or you can just convert to kilowatts. Remember, kilo represents 3, so it's going to be 60,00, which is just 60 kilonewtons, because it would be like 60,000 like this. But these zeros after the comma are not important. So this is kilowatts, sorry, this is power kilowatts. So that is how you are supposed to answer this question. As you can see, guys, it's pretty confusing sometimes, connecting the formulas, because like this one, you had to connect the formulas. It was not direct because we didn't have that, which is the same thing as this one. Also, the potential energy at B, which is that is E top, this at the top here. So as we know that the potential energy at the top is supposed to be M. It was supposed to be like this. Actually, it's supposed to be like mgh. That is what we know. But now, because of the incline now, because there's going to be an angle like this. So as for me, this is the height actually that we are talking about here. So if I write it as h sine theta, as for me, it doesn't sound fine, because this is s, the one that I want to transfer to be here as my height, which is the one that I'm going to use for potential energy. So this h here is actually equivalent to s sine theta, which is the resultant here, s sine theta, which is the displacement from A to B. So it makes sense, not h sine theta. But anyways, that's how they write it, and so forth and so forth. I don't know how, I don't know why, like this. So now it can make sense, because this is the displacement from A to B, and this is the height here, which has been replaced by this. So if I now write as height now, it will not make sense, guys. Truly, it doesn't make sense. Anyways, let's just see what we are talking about. So remember, our theta was on our way to be calculated here. When we said theta, it's arctan 1/20. So let's just have that theta, since we said it's arctan 1/20. So let's just have it, which is going to give us something like 2, yeah, this decimal is too small, 2,86 actually, 86,240 like that, which is gonna be 2,862 degrees. That's our theta. So which means we can now substitute m, which is the mass, that's 900, times g, which is the gravitational acceleration, times this s, which is the displacement from A to B. The displacement from A to B, this one, just like what you use when you are using sine rule, guys. This is s here, and you want to calculate this side, so you've got opposite and the hypotenuse, which is the ratio for sine. So that is what is happening. You want to calculate this side here. This is your height. Are we together, guys, here? All right. So this is going to be your displacement, which is the one that you calculated, then times the value here. And remember, your displacement is going to depend, because we obtained 240, but there was another answer, that one that used another decimal, which ended up as 240,024, if you still remember. So you can use that one. Let me see what I can do here. So like I'm saying, you can use 240,024. All right, so it's gonna depend, times sine theta, that's times sine theta, which is sine the angle that we just obtained now, which is 2, okay, this is sine here, guys, sine 2,862 degrees, like that. All right, so that's what you're going to have in this case, which is gonna give us something like 10 5692, yeah, something like that, comma 995, which is 9951 from this one. But from this one, it is going to be different answer. It's going to be, okay, this is actually, you know what, kinetic energy in joules, this one. So you can convert it into kilojoules if you want. From this value, it is going to change. It is going to be something like 105, but it will be 703 like this, comma 5644. Okay, so you can round off to 3 decimal places, 3 decimal places if you want. Yes, that's what you would have obtained there. Then we are then given that a Houghton train experiences a tractive resistance of 280 Newton per 1000 kgs when it moves. So whenever there is a movement, this train is experiencing a tractive resistance, which is actually the frictional force of 280 Newton per each 1000 kg. So whenever there is 1000 kg in terms of the mass, 208 is going to be lost. So now the question is, if the train exerts a force of 80 kilonewtons here, take note, 80 kilonewton, when it has a mass of 40,000 kgs, calculate the acceleration of the train. All right, so this is the applied force here, which is 80 kilo. So F applied is 80 kilo, which is actually 80,000. Kilo means 1,000, remember guys. And the mass at that moment is 40,000. So which means it is going to determine the tractive resistance, which in this case is the what? Is the force. So how is it going to affect? We are given that per each 1000 kgs, we are going to lose 280 newtons. And now we have got 40,000 kgs. So let's see what you're going to have. Let's divide 40,000, divide by 1,000. All right, that's 1,000 there, which is just, okay, so you're going to remain with 40 there. So which means per each 280, it is now going to be affected by 40, because each 1,000, but we have got 40,000, so we divide these two, then whatever that you get, you multiply to 280 there. So which means our frictional force at the end is going to be 280 times 40, because we obtained 40 there. 208 times 40, which is going to give us something like 1 that's 11200 Newton, like this. All right, so we have the applied force and we've got the force that is resisting, that is opposing. How now are we going to find the acceleration of the train? So remember the relationship between F net, that's F net is actually equivalent to MA, which is the net force. But this net force is also equivalent to the applied force minus the frictional force, because this one will be opposing. The difference between the two gives us F net. So let's find F net first, because we've got the applied force here, 80,000 minus the frictional force, which is 1,000. Is this 11,200? Actually, not 1,000. 11,200 newtons. So we subtract these two, we are going to obtain 68,880 newton. So this is actually your F net, which we say this F net here is actually equivalent to MA. So you can take advantage of that to say 68,880 is equivalent to MA, which is our mass is not going to change, is it, guys? Our mass is what? I'm still using the mass from the previous question. You see now, our mass is 40,000. The mass of the train is 40,000. Okay, so this is 40,000, guys, the mass of the train. So that's 40,000. All right, A. So we use this formula here, F net, your mass here. So you want to calculate A. So you can divide by 40,000. You can divide here by 40,000 like that. So that's gonna give us the acceleration of the train, which is 1,72, actually 1,72 meters per square second, or you can write this as meters per square second like this. It's one and the same thing. So guys, that is how they ask these questions. So I don't know, what you need, guys, is to revise much questions now before exams, because we are almost towards exams, and we have to maximize even in on our revisions. The time that you give should be more now than the time that you used to have before. Now you need more time to revise. More of your time must be on revision, so that you understand. So how do you revise? Work on question papers, revise question papers. The more you do question papers, the more you see your strength in that subject that you're doing, to see that, okay, these questions I can actually answer them if they are to be repeated in that format, but these ones I cannot answer them at all. Then you work on those areas that you are weak at. You work on those areas that you cannot answer. That's the concept. So guys, that's it from us on African Motives, working on engineering science N3. Till we meet again.